So we're dealing with angle of elevation in this video, angle of elevation and depression. So to elevate, or to explain what elevation means, to elevate means to lift or to go higher. So if you're looking straight, if someone is looking straight and then they lift their eyes, there's an horizontal line. Because when they were looking straight, that horizontal line of sight, and then they lift their eyes up. So you created an angle with the horizontal line, and when you lift your and the angle, the incline line of sight, and that angle is called the angle of elevation. All right, and this topic basically use the trigonometrical ratios. So let's get a few examples. The angle of elevation of the top of a vertical tree. Vertical means straight up, right angle. From a man standing on level ground 25 meters from the base of the tree is 38.5 degrees. So he's standing there. What I normally do, I want you to calculate the height of the tree correct to the nearest meter. What I normally is do a little sketch of this. So a man standing on level ground. Right, he is 25 meters away from the base of a vertical tree. So there's a tree there. And the angle, they did not mention the man's height, so we don't take that into consideration. The angle of elevation is 38.5 degrees. He is 25 meters away from that tree. So I do a little sketch first, and then I abstract a right angle triangle. So I give it my own label. This is the man. This is the base of the tree. This is the top of the tree. And this is 25 meters. All right, let me work with that. This is a right angle. So we are given the adjacent. This is the adjacent side. This is the opposite side. This is the adjacent. The ratios that include opposite and adjacent is tan. So tan theta is equal to opposite over adjacent. So tan 38.5 degrees is equal to the opposite. Opposite side is m, small m. This is t. So m over t. Tan 38.5 is equal to 0.795, and that is equal to, we don't know what m is. Mt is 25 meters. So we cross multiply. 25 meters times 0.795 is equal to m. M is equal to 25 times 0.795. That is equal to 19.88. 19.88 meters. So they said correct to the nearest meter. So when I finish solving my question, what I normally do is to read the question again to make sure I did whatever I was asked to do. So first thing first, I read the question twice carefully, and then I solve the question, and then I go back and read the question to make sure I did what I was asked to do. So it's to the nearest meter, it's 20 meters. Okay, so we have a next example here. It says a woman 1.7 meters in height observed the angle of elevation of a tree to be 24 degrees. If she is standing 15 meters away from the base of the tree, determine the height of the tree. So again, I do my sketch, and this is where the sketch becomes important, right? So we have a woman standing on level ground, she is 1.7 meters high. Alright, she's standing 50 meters from the base of a tree. Good. The angle of elevation from her eyes, not from the ground. They mention her height, so it's not from the ground, it's from her eyes. So the angle of elevation is 24 degrees. So which means from the horizontal, this will be 1.7. So when we calculate this distance here, we're not calculating the entire height of the tree. We're calculating from our horizontal line of sight to the top of the tree. And then we will have to add this, 1.7 meters. Okay, so let's abstract our triangle. Right angle triangle, this is 24 meters. This is the woman, W. This is the top of the tree. This is the base of the tree. Not the base, this is here. This is the base. This part here we're talking about. We're going to still call it B. This is 15. So again, we're given the adjacent and we're asked to find the opposite. This is woman, this is common W, this is T. So we have to use tan. Tan is equal to opposite over adjacent. So tan 24 degrees is equal to the opposite side is W over T. Tan 24 is equal to 0.445, and that is equal to W. We don't know what W is. We know T is 15 meters. So we cross multiply. 0.445 is equal to times 15 meters is equal to W. So 15 times 0.445 is equal to 6.68 meters. All right. Now, as I said just now, this is this height, not the entire height of the tree. So we'll have to add that 6.68 to the 1.7, and we get 8.38. So the entire height of the tree now is what we call, well, height of the tree is 8.38 meters, and that is how that works. Okay, so we have another question here, right? And this question is not tricky. It's not tricky. You can get this question. A surveyor stands 100 meters from the base of a tower on which an aerial stands. He measures the angle of elevation to the top and bottom of the aerial as 55 and 51 respectively, and they want you to calculate the height of the aerial. So again, sketch. Surveyor stands. They did not mention the surveyor's height, so we don't have to take that into consideration. Stands 100 meters from the base of a tower. On this tower is an aerial. I'm thinking that is one of those antenna thingies. So this goes here. That's the angle of elevation from where he's standing to the bottom of the aerial. That is 51 degrees, sorry. And from where he's standing to the top is 55. Not this little piece here, the entire thing from here to there is the 55. So what we have here is two triangles. So we separate the two triangles and then we subtract these two distances. To get this distance alone, we get the entire distance, then we get this short distance, then we subtract, and then we'll get this one alone. So let me set it up for you. You're going to do it. You will have the first triangle, big triangle. This is the man. This is the base of the building. This is the top of the aerial. So we call that T. Top of the aerial T, bottom of the aerial we call that A. This is the base of the building, and this is the man. So we get a clear separation. So this is 55 degrees. This is 100 meters. You have to use tan. And then we have the other triangle, the short one. Man, base, bottom of the area. This is 51 degrees. This is 100 meters. You have to find the area. So find these two different lengths. This one, subtract them, and you'll get the height of the area. Okay. Now, angle of depression. So now, if you're standing on top of something, or even if you're standing on level ground, you first look straight, and if you want to look down, you'll form an angle with your horizontal line of sight and your decline line of sight. The angle formed there is called the angle of depression, looking down. So I'm going to work another example here. Well, I should show you how this works. Well, I'm going to show you in a diagram. Let's read this question here. It says a girl 1.0 meters in height standing on top of a vertical building 45.0 meters high sees a car some distance away when the angle of depression was 55 degrees. What distance was the car from the base of the building on which she stood? So she's standing. We have the building here. She's standing on top of this building. She sees some cars some distance away, rims and thing. The building is 45 meters high. She is 1 meters high. It's pretty short. So, and first of all, you have to get your horizontal line of sight. For depression, you have to draw that first. Then your decline line of sight. So the angle there is 55 degrees, not the angle in here. Make sure you know the difference between the angle in here and the angle there. So don't make the mistake and put that 55 in there. It's here. It's the angle formed with the horizontal line of sight and the decline line of sight. So how would you draw this triangle? Because of the alternate angle property, this angle here will be 55. Or, that's one way, so you can draw a triangle like this. And this will be 55. And then this height here will be 46 meters. 46.0 meters. Why 46? Because you have to take into consideration her height. Or, you can do it this way. You can use the horizontal line of sight. You can use that. You can use this triangle at the top here. Why? Because if you look at it, it forms a rectangle. So this length here and this length here at the top here will be the same. So this will be 100 too. 100? No, we don't know. Yeah, sorry. This here, sorry. This side here, the building here, and this here. So this will be 46 meters as well. And then you still can find, if you find this distance here, you're still finding the distance at the bottom there. Okay, so we can use this as well. And here will be the 55 degrees. So I'm not going to solve this. You have all the explanation you need. Set it up. Let me set it up for you. You can use either this or this. So if you decide to use this one, same thing. You're given the opposite and you're asked to find the adjacent. Here is the same thing. You're given the opposite and you're asked to find the adjacent. This is tan theta is equal to opposite over adjacent. We'll have to divide here. So tan 55, however you label it, base of the building, top of the building, car. Base of the building, top of the building, car. So tan 55 is equal to B, this is C, this is T, is equal to C opposite over T. And then you proceed to solve that. So let me explain this one. It's just an explanation. Again, you will have to solve this one because you know how to use the trig ratios. From a central local point, from a coastal local point, P, 100 meters above the sea. A sailor sees two boats, A and B, in the same direction. The angles of depressions for the two boats are 15 and 23 respectively. They want you to calculate the distance between the boats. So again, the sketch is very helpful. Sketch, sailor, boat 1, A, boat 2, B. Alright, this is 100 meters above the sea, so this is the sea. The angle of depression from here, first for depression you have to draw the horizontal line of sight. Always the horizontal line of sight. The angle of depression for this boat will be 15 degrees. That one is smaller than the other one. Then the one here will be 23 degrees. So you have your sketch and you can abstract your triangle. So we have this here. This is the one with the 23 degrees. This is 100. This is the C. This is the top of the tower. This is boat A. This is, let me draw the next one. This is the C, top of the tower. Boat B. This angle here is 15. Okay. So again, this will be 23. This will be 15 degrees. This will be 100 meter. You cannot forget your units. And what do we use here? We're given the opposite. I'm going to solve this one. You're going to solve the other, and then you subtract the longer side, the shorter side from the longer side. So this is the opposite, this is the adjacent. So tan has to be used. Tan theta is equal to opposite over adjacent. Tan 23 degrees is equal to the opposite side is A, this is T, A over T. Tan 23 is equal to 0.425, and that is equal to A is 100 meter. We don't know what T is. So we bring over the T. So T times 0.425 is equal to 100 meters. And then we take over that 0.425. 100 meter divided by 0.425. T is equal to 235.29. 235.29 meters. So I found this distance. This is the shorter distance. This one has to be bigger. So find this distance, then subtract this distance or this distance from that one, and you'll get the distance between the boats. So there is your video on elevation and depression. Your next video will be on sine rule and the cosine rule and bearings.